Okay, so on the first question, it says the island of Pandora gets rain on half the island 50% of the time. So half the island gets rain 50% of the time. So what's the probability this half gets rain? 50%. What's the probability of the other half? It gets rain 30% of the time. So remember we did expected value, we had the probability, and then we had like the dollars or whatever it is that, well, this is the land mass. So how much land of it gets rain? Half of it, and the other half gets that. So half times 0.5 is 0.5 times 0.25, which is 0.25. And half times 0.3, well, half of 0.3 is 0.15. So if I add those together, remember our expected value, we just added them all together. That makes 0.40. In other words, there's a 40% chance that the whole island will get rain. So that's how we would do that first one. The next one says, suppose that you expect a score of 90% when you study for quizzes and a score of 50% when you don't. The probability that you study is 85%. So that you study is 85%. So what's your result when you study? You get a score of 90. So 0.85 times 90. So the score, or what you expect, and the probability that you get it. So the probability you get a 90 is 85%. You don't study. So if you study is 85%, you don't study is 15%. Remember, it's 1 minus this. So that you don't study is 15%. Okay? So the probability that you study is 85%. Compute the expected average of all your quizzes. So when you don't study, the probability is that you don't, probability of not studying is 15%, and your score is 50%. So now we just go to our calculator. We go 0.85 times 90, and then we have 0.15 times 50, and I add those two together. So that was 76.5 and 7.5. Okay, so I have 76.5 plus 7.5 is 84. So your expected score is 84. So remember, your expected value is always the percent and then the event of whatever it is, uh, test score, landmass, dollars. Um, so your expected value, the percent times whatever your event is, plus the percent times the event, the second event, and so forth. Okay, however many events we have. So in this case, we just add these two together because that's all we have, and our expected value is 84. So the next one says below is a playoff matrix for a game involving two players. Player one can use either strategy A or strategy B. So we have this chart. It says player one can either use strategy A or B. So player one can choose A or B. Okay, so player one, if he chooses A, or player one chooses B. So if he chooses B, he's either going to get 10 or 4. If he chooses A, he's going to get 7 or 10. Okay. Player B or player 2 can defend against either strategy A or strategy B. So if player 2 defends against A, he gives up 7 or 10. If player 2 defends against B, he gives up 10 or 4. So sketch a graph showing two lines on the axis below. One line giving the expected gain for player 1 if player 2 defends against strategy A. The other giving the expected gain for player 1 if player 2 defends against strategy B. Label each line appropriately. Yeah, that makes about as much sense as a mud puddle, huh? So anyways, so player 1, expected gain. And probability, player 1 uses A. So this is our probability, and this is player one expected gain. Okay. So this is 0, this says 1. And up here is 10. Okay, so let's just look at these lines down here. Line 1, expected gain for player 1 if player 2 defends A. So player 1 if player 2 defends A. So in this case, if the player expected gain for player 1 if player 2 defends A. So if he defends A and player 1 uses A, his expected gain is 7. Okay. If player 1 uses B, his expected gain is 10. So on this first line, so if player's expected gain probability, player 1 uses A. So if player 1 uses A, he gets 7. So it's like right here. If the probability player 1 uses A is 0, in other words, he uses B, he gets 10 because player 2 is defending against A. So player 2 defends against A. Well, if player 1 uses B, he gets 10 yards. So the probability that player 1 uses A, if it's 0, then the expected gain is 10. Player 2 defends A, and the player 1 uses A, he only gets 7 right here. So it looks like this. Okay. Now the next one is our orange one. It says expected gain for player 1 if player 2 defends strategy B. So strategy B, if player 1 uses A, if A is used, so if A is used against strategy B, he gets 10. And so player B is still defending strategy B. So if B is used by player 1, then he gets 4. So probability that player 1 uses A. So if A is used on this one, so if A is used, so probability player 1 uses A. So if A is used, that's the 1. We have a dot up here at 10. So remember, 1 means that it happens. So player 1 uses A, that's a 1. He used A, so that means 10. 0 means it doesn't happen, so that means he didn't use A, which means he used B. My gain is 4, so somewhere like right there. Connect those dots. Okay, and then this is kind of what we're after, is this intersection right here, kind of this probability and the number of yards or number of whatever it is. So this is like, if I had drawn it really well, 50, that'd be like 75. So that's like 68. So if he uses A 70% of the time, he can plan on getting 8 out of it every time. So something like that is what that reads like. So it's an interesting question to look at and say, what does this point in the middle mean? It means that player 1 should probably use 70%, uses A 70% of the time against either of these, okay? Because then he'll plan on getting 8 yards. So that's how you'd read that. Okay, so to solve this problem, we're going to do something interesting with this, and we're just going to pretend that there are 1,000 people of you. like 1,000. So chance you have. So this is for you. So we're going to pretend there's 1,000 of you. Okay. So what we're going to do is we're going to make a table based on there being 1,000 of you. Okay. We could use another number. I just chose 1,000 because it works out nicely. And we're going to put swine flu in here, bird flu in here, and llama flu here. These actually are types of flus. Nowadays, we could probably even put coronavirus in here, but these are the swine flu, the bird flu. The llama one's a little bit out there, but the other two have definitely been uh, have been about. So let's just say based on there being 1,000 people, if we had 1,000, 500 of them have the swine flu. 30% of the 1,000 means that 300 of them have it, and 20% of 1,000, so 0.2 times 1,000, move the decimal over one place, now it'd be 2. So 0.2 times 1,000. So that's 200. All right, so we know how many people, based on the original information, if these were all you, there'd be, 1,000 of you would have 500. 500 out of those 1,000 would be swine flu, 300 would have bird flu, and 200 would have llama flu. But now it says you have anemia. Okay, so now it says have anemia. So given that you have anemia and the swine flu, so 20% of these 500, okay, so 20% of 500 is 100 of them. So that means that there are 400 that don't have anemia. Now, bird flu, there's 300 of them, but that's 30%. So that's 30% of these 300, which is 90, which means there's 210 that don't. Okay, just to check our math, 0.3 times 300 is 90. And now our llama, there's 80% of the people are anemic. So out of these 200, so that's 160. Now if I did totals down here, this is going to be 500 because it says swine flu is 50%. This is 300 because that's 30%. And this is 200. So again, I just chose 1,000 because it works out nice to kind of give you an idea of how this actually works. And so if I add these together, that makes my 1,000. And now if I add these together, 160 plus 90 is 250, plus another 100 is 350. If I add these together, 40 plus 210 is 250, plus 400 is 650, and it adds up to be 1,000 again. Okay, so realize we could really work with percents, and we could have just said 0.2 of 0.5 and 0.3 of 0.3 and 0.8 of 0.2, but this makes more sense to think of it as 1,000. Okay, so now that we have this information, we can look at it this way. So out of the people that have anemia, okay, so out of anemia, there are 100 out of 350 that have the swine flu. 90 out of the 350 have the bird flu, and 160 out of the 350 have the llama flu. Because you're in this category, you have anemia. Okay, so that changes a little bit. Instead of being in this category, you know you have one of these, but based on you having anemia, now we know the chances of you having that. So 100 divided by 350 is 28.57%. So this is 28.57%. Or you could be this group, 90 out of 350, 25.7%. Or 160 out of 350. Which is 45.71%. So if we added all those together, it'd make 100. And just to show you, plus 0.2571 plus 0.2857, which is really close to 100. Okay. So anyways, based on these, the probability that you have one of these to begin with, and then giving you more information, you know you have anemia. And with this information, we can say, you know what? It's most likely that you have the llama flu because you have anemia. Because you're anemic, it's most likely you have the llama flu. Doesn't rule these out, but that's the highest probability. Okay, so that's all that means. It's just a way of saying, based on another piece of information with this, what's the likelihood that you have these now? So anyways, that's the bottom of that page, and that gets you through chapter 8.